And hello there folks, this is your Uncle Troy. Today we are playing Minecraft. We are playing the Feed the Beast mod pack. This is my technical series where I explain to you how to do things. Gonna mention I have changed my tree farm slightly. I'm now using redwood instead of fir. I seem to be getting much less lag. So unfortunately the redwood trees seem to grow slightly slower. But I'm in fancy graphics mode, far render distance, and I'm actually getting decent frame rates today. But we're going to forget all that and go down in the mines because we are going to do some mining. Let's see. Need to pick up some more nephews. Three more of these. And we need some charcoal. Wherever shall we get some charcoal? Yes, I have one, two, oops, and now I'm stuck. Stop. There we go. I got 4 of these barrels full of charcoal. We are now in the redwood business, as you can see. Although there may still be some fir logs in here somewhere. Nope, looks like it all redwood. And oops. And then I complained about these redwoods not growing fast enough, and then 2 more grew while we were talking. But today we're going to talk about a program I wrote called Miner, which mines out 3x3 tunnels. These programs are available for download. Check out the video description. And Miner creates this right here. And then of course these 3x3 tunnels are perfect for branch mining off of. Yeah, down here you can see we have done many branch mines off this 3x3 tunnel. That's a different program. Actually, let's go down to this level here. Alright, so to make a 3x3 tunnel, you put the turtle there. It's usually convenient to put a barrel underneath, or not a barrel, a chest underneath, because the turtle will return and put things under there. This is called, no, not tunnel, it's called Miner. And let's say we want to send this guy out 64 blocks. Now, this turtle's named Eddie. Slot 1 is fuel. And I think about 16 fuel is enough for him to go 64 blocks and back with no problem. 8's probably sufficient. Now in the second slot, we're going to put torches. And he puts torches down every 8 slots, so if we're sending him 64, 8 will be sufficient. And in slot 3, optional cobble. And if you put that there, or anything here basically, then if he encounters an open space under him, he will fill it in with cobble. And then press enter when ready, and we send him off. And it turns out he has plenty of fuel, so he probably will not use any of this fuel here. But he is making him a 3x3 tunnel and filling in underneath. Now unfortunately he can only see what's directly below him, so he has to do this little dip thing every time he digs, just to make sure there's not a hole underneath that needs filling in, like that. And if he fills up his inventory, as you can see it's filling up pretty quick here, then he will come back and dump it into this chest here. And my original plan was to run pipes all round through here and have an army of turtles dropping in the chest that were running transport pipes and up. But the turtles, I don't know what I want to do with that yet. But you probably want to know, well, how does this program work? Well, let's put down another turtle, just so we can access this program, Miner. Alright, this is the tunnel mining program with return. Mines, places, torches, etc. Variables. Now, I always start off with turtle select 1, because I always put my fuel in slot 1. Other people might put it in slot 3 or 4 or 8, 16, whatever. But I always start with slot 1. Now, local targs. Turtle arguments, and this ... when you type in, let me go back here, if you type in Miner and say 64, That 64 is the arguments, also known as the parameters. And so when the miner program runs, the turtle says, hey, they want to run this with parameter 64. That's what the ... is that 64 or whatever else it is that we said we wanted to use for an argument. Now, the argument might be a letter, it might be a number, it might be a word. So we set it to a number. Rather, the first argument set to a number. And then we say to go equals to go or 1. And that basically means if to go doesn't exist or is 0, then that or 1, that comes back as 1. Kind of a Boolean math there. Let's check on our turtle, see how he's doing. So he's moving quite a right along here. And as you can see, 8 spaces in, he dropped a torch, as is the custom. Okay, so local torch and local cobble. Local, I may have mentioned, just says that this variable or procedure or whatever function, whatever, is only used in this program. Basically, I'm defining these variables now that I'll use later, and I'm going ahead and set them to 0 because I'm pessimistic, and we're just going to assume that they'll be 0 later. Alright, this next section here, term clear, just clears this screen. Set cursor position 1, 1, sets it up in this corner where this T is right here. You're going to print the computer label and say at your service, and then we're going to print a blank line, and then we're going to explain how to fill in the program. It says place fuel in slot 1, torches in slot 2, optional, cobble in slot 3, optional. And that's why we set the variables torch and cobble earlier. That's what we're going to use to determine them. And then press enter when ready, and then read input, waits until you enter something, and actually it's multiple characters. You could sit there all day, but until you hit enter, it doesn't do anything. Alright, so starting out, I wrote this program back before I had the automated charcoal farm, and coal was precious, so we always supplied the turtle with coal, just enough to get the job done. So we check in the item count of slot 1, which is right here, and if that is less than 1, then we say no fuel, abort, and we use the quit command. Now actually this is the wrong quit command. This actually throws up an error, but it still exits out the program, so that's good enough for me. Somebody needs to write in and tell me what the actual quit program is, if you don't mind. And again, we're going to assume that torch is 0, because that's just the way I write things. But if item count in slot 2 is greater than 0, then we'll assume it's torches and set the torch variable equal to 1. If the item count in slot 3 is greater than 0, then we'll assume we put cobble over here, and we'll set cobble to 1. Now if the torch isn't there and the cobble isn't there, then torch will be 0 and cobble will be 0. And I think I've probably written this badly. And I hope that it was in the game and not in real life, because it's been getting a lot of rain here lately. But we're going to use these numbers later. And I is some kind of variable that for counting variable, probably index variable, that I've set to 0 for some reason. Now we've got various functions, which we're going to skip by real quick and get down to the main meat of the program, and then we'll come back and cover the functions later. Alright, main loop. Here's that I we set. Now we probably could have set it right before the main loop, but I think I may reference it somewhere in some of these in some of these functions right there. So that's a bad programming practice, by the way. What I should have done is, if I wanted to use the value of I in a function later, what I should have done was use I as one of the parameters, one of the arguments that I was sending to the function. That's the proper way to do it. Okay, so we're going to start off by repeat. Simply says repeat this until something is true. And the until that matches up this repeat is way down here. Yeah, until I is greater than or equal to go, which is the parameter we set to start. So go back up here. Oops. So at the start of everything, we're going to say, okay, I is 1 greater than it was. Set I equal, figure out what I is, add 1, and then store the result in I. Clear the terminal, set the position up the upper left-hand corner, up here, and local PCT equals I divided by to go times 100. And this is a little bit of magic here, but PCT is percentage. That's just how I was taught to abbreviate it. So our current count divided by how far we're going will give us a fraction from 0 to 1. Multiply that by 100 to get percentage. And then we're going to say we're mining I of to go. So 1 of 64, 2 of 64, 3 of 64, etc. And then some dot dots. That just means add the rest of it to what we're displaying. Percentage, and then the percent sign. Yeah, as you can see, he is currently at 46 of 64, which brings him up to that many percents. And he's still got that much fuel. I added that later, because at some point I decided I wanted to keep track of fuel. And if you just use the miner pretty much exclusively, you end up looking like this. So he hasn't come back to drop anything off yet. Good, good, good. All right, so the next line here is print fuel, which turtle get fuel level, which we showed there. So he's still got like 5,000 fuel, so he doesn't even need this charcoal. All right, then we're going to call the procedure myDig, which, if I remember correctly, digs directly in front of you, and I think moves forward and digs above and below. Well, what the turtle's been doing here. Digs, moves forward, up, and below. Alright, then he's going to turn right. Turtle turn right. He's going to do the same thing on this side. Then he's going to turn around. Actually, he's only going to go 180 degrees. He's going to move forward back to where he was, but now he's facing the other way. He's going to dig up, down. He's going to turn left, or he's going to turn around. He's going to move forward back into the center of the aisle. He's going to turn left, so he's facing back the way he was. If to go is greater than or equal to 8, meaning we're moving at least 8 spaces, and torch is greater than 0. Remember before we said torch was set to 1 if we had torches. Then if I mod 8 equals 0, and mod here is a division sign. Now it's not the same as this. It is a percent sign here. But what if you did I divided by 8, it would take the value in I, divide by 8, and give you the answer. If I was 16, it would divide by 8 and give you 2. But the modulus, I think is the full name of it, what that does is it divides by 8, and then it gives you the remainder. So if you divide, say, 16 by 8 with this operator, it says it'll return 0 because I was evenly divisible by 8. Now if I was, say, 18, then I divided by 8 is 2, remainder 2. It would have returned 2. But if this is 0, meaning every 8 slots, then turtle select 2, which means select this slot here, and place down. So place that under the turtle. And then go back to turtle select 1, because we always select 1. And the reason I do that is if he runs in, if this is coal or some other fuel source that he can mine, oops, turtles come back, and he is emptying his inventory. And then he's going back. So even though he was almost finished there, he didn't have quite enough inventory space for everything. So he brought it all back. So he'd probably go down there, dig about one more time, and then come back and dump it again. So if he mined some more well, this is charcoal, but if this was regular coal, if he mined coal, the turtle would try to put it in the slot that's selected. And if that fails, then he would go into the first slot that did match or was empty. But if I'd left, say, this selected, and he mined something that matched this, he would try to put it in this slot, fail, go into the next slot. And it wouldn't be until he filled up all the slots that he come back here. This way, if you're fueling with coal and encounter more coal, he'll always have fuel. And this end, every statement pretty much needs an end statement. So, yep, there he comes back. So now we're going to check to see if turtle's full. Now, I have a fairly lazy way of checking to see if the turtle is full. I just check to see if there's anything in this last slot here. And if that is true, if the count of items in slot 16, 1, 2, 3, 4, blah, 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 16, is greater than 0, then we're going to discard, called the discard function. And then once that's done, we're going to again select 1 and repeat until I is greater than or equal to go. I love it when I type in comments like, let's assume that worked, and he made it. So, assuming we made it down to the end of the row, all the way down there, we're going to say for r equals 1 to go, do, and that's a for loop that starts at 1 and goes to go, and then does whatever is in this section here. We're going to check fuel level. If it's okay, if it's not okay, we're going to add 1. And then while the turtle can move forward, so we'll attempt to execute this command and then return the value to while. And then, so if it did move forward, it'll say true, and we'll just fall out of this loop. But if it's false, then it's going to try to dig in front of it. And as long as there's something in front of it, it's going to keep trying to dig. So if, for example, sand or gravel has fallen into the path the turtle had taken before, it will keep digging until it's cleared out. Or if, for example, the turtle has dug through lava and water and they're now coming together to form a natural cobblestone generator, hopefully he will be able to dig and get through. So he is going to go 1 to go, which if he's all the way down at the end of that, that should bring him right back to where he started, which apparently it has. And then he's going to simply go through 1 to 16, select each slot and drop down, which if there's a chest down here, he will drop it down into the chest, as you can see. If there wasn't, there'd be a pile of items right here that I'd have to come by and manually pick up. But the purpose of this was that I could take these items, collect these items, put them in this chest here, doop, 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 which I've explained earlier. Flip this little switch, and these items will be sucked out of this chest, and we'll go up this pipe. Whee! And up there I've got a primitive sorting system worked out. And then I say that, I'm going to go up there and there's going to be stuff laying all over the floor or something. Then we say turtle select 1 because just end up being selected there, and that's the end. So now we've got to cover, that's the basics of the program, but I've kind of glossed over what these functions do, my dig, turn around, etc. So we're going to go back up to the top here where we start defining our functions. Alright, this function is, and ideally there should be a little comment here in front of every one of these. It says, refuels turtle to the specified amount if necessary. And then something like call often or call in your main loop or whatever. Function tfuel amount, which means the function name is tfuel, turtle fuel, and if we give it a parameter, if we give an argument, it'll be available inside this function as the variable amount. So, if the turtle get fuel level, which is the amount of fuel left in the turtle, in this case, for this turtle, it's 49.43. If you type Lua you can go into the interactive Lua prompt as it says. You can type turtle commands directly. Alright, so if it's less than 16, meaning we can only move 15 or fewer spaces, then select slot 1 and refuel by that amount. And if there was, for example, 48 in here and I just said refuel, it would try to fuel with all 48. But I wrote this program back when fuel was scarce, so I only wanted to refuel one at a time and keep my turtles fairly low level. That way I didn't use all my fuel filling up a turtle to go 100,000 spaces, but then I have another turtle that can only move 5 spaces. Alright, so that's fuel level. And you call that every so often. You don't have to call it every time the turtle moves, but you do have to call it. You can't let the turtle move 17 spaces without calling it, because then there's possible that he will run out of fuel before he finishes. And I could set this something outrageous like 10,000, and he would keep his fuel level at 10,000. And thinking some of my later programs I might have done that. Alright, so function turnaround, all this does is cause the turtle to turn right twice. When I was being taught, I think Pascal programming, or maybe it was C programming, like 25 years ago, back when Pascal and C were still languages people would actually use, I was basically told anytime you do something more than once, it needs to be in a function. And sometimes, even if something is only being done once, it needs to be in a function if it makes the program easier to read. So anyway, so even though all he's doing is turning right twice, which will have him facing back the way he was, we put it in a function. Now, function U and D, up and down. Actually, I think I copied this from somebody else, which is why it's named funny. But turtle detect up tells the turtle to look above and see if he sees a block there. And if that is the case, then he's going to dig up, he's going to wait half a second, and he's going to keep doing that until he does not detect above him, until detect up is false. And that is because you may have sand or gravel or something else that falls above you, so when you dig, it just falls down on top of the turtle. So you need to keep digging over and over and over again, because if you don't, when you move forward, the block will fall behind you and you can get trapped in here. And let's see, we need to exit this Lua prompt back to here. In fact, I'm going to send this guy off another row. Let's see, he's a few spaces over, so we'll say 66 this time. Since he's completely full of fuel, because we checked earlier, we won't bother putting more than just one there to full the fuel check. 1, 2, 3, 4, 5, 6, 7, 8. There you go. You take off. Have fun. Alrighty, so he's going to look above him, keep digging until that's false. Then he's going to look below him, and he's going to keep digging below him until that's false. And probably don't need to that check, but I was in a very cautious mood when I wrote this. Now, the indentation gets messed up. I think it's because I'm doing a lot of this programming in an external editor, and then the tabs aren't translating over properly. Alright, so if cobble is greater than 0, which means in that initial check, if it looked in slot 3 and saw something, which in this case is cobblestone, but I could just as easily have put down dirt or maybe regular old stone and had it pave it with that. But I use cobblestone because he's likely to dig lots of cobblestone, which means this slot will always be refilled by the cobblestone he's digging. So he'll never run out of flooring material. Alright, so if cobble is greater than 0, meaning the initial check we made was greater than 0, then we're going to move down a slot, or move down a, that's that little dip he's doing there. Move down and then try to place something underneath. He's going to go down, he's going to try to detect underneath him, and if that's false, then he's going to select slot 3, he's going to place beneath him, and then he's going to go back to slot 1. And then when he's finished with that, he's going to take a step back up so he's in the middle of the row again, because he can dig up and down so easily he wants to be in the middle of the row while he's doing all this. You can see there's a lot of unnecessary movement. He's going up, down, up, down. He's going left and right. So this is not a very efficient program. Alright, and that's the end of the up and down. So, my dig. My dig, talking about my dig. Oh. Alright, so first thing my dig does is checks the fuel level, which we've already explained before. And then if turtle detect, meaning if he sees something in front of him, he's going to repeatedly dig and sleep until he doesn't detect anything anymore. And that's, again, if sand or gravel is falling, or if there's a natural cobblestone generator in front of him. And then once the path is clear, he's going to move forward. Then he's going to call that up and down thing that we discussed before, where mine's above and below him. And I don't know why I'm gesturing with my hand above and below, because you can't see that, so I need to grab the mouse here. Now, if he did not detect something in front of him, well, then he just goes ahead and moves forward without digging, and again looks above and below. Now, discard, run back to start, and drop off items. So, suppose he's digging. He's not done that yet, but let's suppose he's digging out here, and he fills up. So what he has to do is he has to turn around, run back here to where he's back where he started, over this chest, drop off his items, and then go back to where he was. And as long as you go straight path like this, that's pretty easy to calculate. So he's going to turn around, so he's facing back the way he was. And then for F, just a counter here, from 1 to the current I, which I set up before, the I is a global variable for this, for 1 to I, which is how far we've gone. We're going to do the following. Well, first we're going to check our fuel again, and then we're going to try to move forward, and if we can't, we're going to dig until we can, and we're going to do that all the way back to where we were. Now, at this point, we should be standing over top of this chest. So, for x equals 2 plus torch plus cobble to 16. Now, this is where we get clever. Alright, we're going to start. We know that the turtle will at least have fuel in slot 1. He may have a torch in slot 2. He may have a cobble in slot 3. If all we'd given him was fuel, then his inventory might look like something like this from the various things he's been digging. So, we would start in slot 2 and go up to 16 and turtle select in that slot, and then we would drop below us whatever's in that slot. However, if we had given him torches, we would not want to lose all our torches at this point. We would want to start here in slot 3 and drop everything. So that's what 2 plus torch, because remember, if we have torches in the inventory when we start, we set a torch equal to 1. So 2 plus torch would equal 3, so we would start here and drop off everything. Then the kicker is, if we also had cobble, then cobble would be equal to 1. So we would say 2 plus 1 is 4, so we would start in slot 4 and work our way down to 16. And that's what that little bit of magic there is. And magic is my term for anything that's not immediately apparent. I had a teacher a long time ago who just could not stand magical programming. You had to explain everything, and he would have insisted upon that calculation being in like 3 separate lines, each with a comment explaining exactly what it was doing. So when you're done with that, you turn around facing back the way you were. You go back to where you were by doing an I, F equals 1 all the way to I. Check your fuel, try to move forward. If not, dig, keep going. When you get all the way back, then you're going to go back to slot 1 and keep going. So he is still not dug enough, and actually his inventory doesn't fill up as fast when he is placing down, because some of the things he's digging get placed down like that. So let's see how he's doing. He's at 40 of our 66, or about 60%. Oops, just went 62. His fuel level's still fine. As you can see, he's picked up quite a bit of cobble, some tungsten, some iron, some gravel, and he's not quite filled up yet. If he's mostly finding, and most of the time he will, of course. Oops. Is that diamond? That's diamond. Ha 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 ha. If he was encountering several different types of ore, then these would each take an inventory slot, and even though he didn't have as many total blocks, he would reach inventory slot 16 faster, and he would return to drop it off. Oh, it must have been 8 since the last one. 1, 2, 3, 4, 5, 6, 7, 8. Yep. So now he's decided, yep, I've got to go back. As you can see, he started here at slot 4, and he's dropping all this off into the chest. Then he's going all the way back, and when he goes all the way back, then he'll set it back to slot 1. And look, more cinnabar. Anybody want to tell me what that's for? In Minecraft, in real life, anything? Alright, so that's how the program Miner works. This is available for download on my website. Just follow the link in the video description below. This is Uncle Troy signing out. Please have a good night.